Hey guys, so day two, we're still going to continue talking about similar polygons, but today we're actually going to be talking about how do you find a missing side when you have two similar polygons. All right, so let's go through and review a couple things. Oh, actually, before we can get into it, here is today's objective. Again, you're going to have similar figures, right? So again, you'll have an image that was dilated. So what we're going to do is we're going to use that understanding of similar images to find missing sides. For example, here we're going to be trying to find missing side X. We're going to be comparing the two similar figures. All right, so what is similar, right? What are similar polygons? Careful not to confuse that with congruent. Well, the last unit we were talking about dilations. That is when you take a pre-image and you either shrink it or expand it, right? You're either enlarging or reducing. That is what dilations are. So if you take a look going from your pre-image, let's say A, B, C, D here, to your image, W, X, Y, Z, it got larger. It was scaled by specific scale factor, right? So a couple things. Similar polygons, they have the same shape. Notice the shape did not change. It's not like it turned into a star or it turned into a triangle, right? The shape stays the same. It's just different size. It's just a different size. So again, this is when you have similar polygons. Now, a couple of other things to note here. Corresponding angles are congruent. So those angles that match up are going to be the same. For example, here, angle A, let's say this was 30 degrees, it would match up to angle W. So those corresponding angles would be congruent. They would be exactly the same thing. That would also be 30 degrees. Just because, again, it was dilated doesn't mean that the angles themselves are changing. If it is a perfect dilation, the angles should have stayed the same. Now, what about the sides? Well, the sides is what are similar, right? All sides are equally scaled, right? If it was a true dilation, then everything should have been scaled by the same scale factor. What I mean by that, take a look. How do we go from 5 to 15? You multiplied by 3. How do you go from 3 to 9? Multiplied by 3. How did you go from 4 to 12? Multiplied by 3. How did we go from 2 to 6? Also multiplied by 3. Whoops. All right. There we go. Okay, so and then we also have similarity statements, right? So again, when we know that two figures are similar, we write a similarity statement, right? And again, the order does matter. It's basically a statement that's saying what is matching up with what. This is just really a matching game. And again, that little squiggly right there, that is what we call similar, right? That little symbol right there, it's referring to similar, not congruent. Careful not to confuse that with congruent when it has the equal to part at the bottom, the equal sign part at the bottom. So they're not congruent, they are similar, which means, again, one of them is just a dilated figure of the other, right? And the order does matter. For example, here, angle A would match up with angle W, right? We see that in the actual figures. Angle A would be the same, would be corresponding to angle W, right? And all the other angles work the same way. If you're talking about sides, well, the side from AB, so going from A to B, that would be corresponding, that would be matching up to WX, from W to X. So again, we use these similarity statements to our advantage. You know what's matching up with what. The last thing here before we get into examples is proportions. Well, a proportion, guys, that's basically when you set two fractions equal to each other, one fraction that is equal to the other. Now, sides of similar polygons are proportional, right? So sides of similar polygons are proportional, and we're going to use that to our advantage today. We're going to be taking a look at two sides, and we're going to be comparing them and using it to our advantage to find a missing side. So here, for example number 1, it says use the similar figures. So we do know that these are similar to solve for the missing side length. What side are we trying to find here? We're trying to find the missing side X. It says set up a proportion statement to help. So basically what we're going to do here is we're going to compare two sides. Obviously, I will be wanting to compare this side here from D to F. Let's actually start. Let me start here. So DF is corresponding to which side on the previous one, from A to C. So these sides here, these sides are corresponding, right? These are the sides that match up. So let's go ahead and set up a fraction comparing these two things. Now, when you set up these fractions, it's up to you which triangle, in this case, which triangle you want to begin with, but you have to stay consistent. Let's say if you want to write the fraction x over 15, if I use this triangle first, then I have to be consistent for the next fraction that I write. So again, it's completely up to you. You could have also written it 15 over x, but that means you're always going to start using the smaller triangle before you start using the bigger one, right? 15 over x. You want to stay consistent. You want to stay consistent. So what I'll do here is I'll work from left to right. So let me compare this side from A to C. That was 15. Well, that's corresponding to DF, which is x. And we're going to set that equal to, we're going to say because it is proportional, since they are similar triangles, we're going to compare that to another side. Let me set that equal to, and let's see if I can use a different color here. 15 over x is equal to, find a different color. I'll use the left side here, from A to B and D to E. Those are also the other sides that are matching. So again, remember, I used 15 over x. I'd better set it equal to 5 over 10. You want to make sure that you're consistent. You're consistent when you're writing these fractions. All right. If you're going from the smaller triangle to the bigger one, make sure you stay consistent. So take a look at this proportion that I just set up. Okay, I have 15 over x is equal to 5 over 10. We can actually go through that by just simply cross multiplying. If I cross multiply this way, what is x times 5? Well, x times 5 is 5x. And that is going to equal, if I multiply the other way, 15 times 10. Well, 15 times 10 is 150. If I go through and just solve this one-step equation by dividing both sides by 5, 5 divided by 5 is 1, or 1x, is equal to 150 divided by 5 is going to give us 30. 30 is equal to x. So again, just by comparing two sides, setting up that proportion statement, we can go through and find a missing side. Sorry, technical difficulties as I go through this video, but thank you for bearing with me. All right, let's try it one more time. So it says, number 2, use the similar figures to solve for the missing side length. So again, we know that these are similar, right? We know that one of them is just dilated. So let's go through and set up a proportion statement. So I know here we see x, right? This top side. So I'm going to compare it. Again, I want to compare that to its corresponding side, which in this case, take a look. This angle that had 3 little symbols, this angle also has 3 little symbols. And then down here to the one that has 2 symbols. So we're going to compare those sides, right? It's just a matching game. It's just a matching game. So let me write 5 over x. So I'm going from left to right, be consistent. 5 over x, we're going to set that equal to, we'll find another side that matches up. I'm going to use the bottom of the triangle now. Let me use the bottom here from that one angle, right? That one angle symbol across the bottom to the one that has 2, across the bottom to the one that has 2. Those are the other 2 matching sides. So if I used 5 over x, then I better stay consistent. I'm going to say 4 over 2. So there's my proportion statement. I just have to go through and solve this equation. If I multiply across diagonally, right? Cross multiply. X times 4, or 4 times x is 4x. If I multiply the other way, 5 times 2 is 10. All right. Oops. Let's keep going through. If I go ahead and divide both sides by 4, right? That's 4 times x, so we use the inverse divide. 4 divided by 4 is 1, or 1x, is equal to 10 over 4. I can actually do better than that. I'm actually going to go through and simplify by, let's see, what can I divide by 2? I would end up with 10 divided by 2 is 5. 4 divided by 2 is 2. So there we have it. That is the side length of x here. It's 5 over 2. Or if you actually divided that, you would get x is equal to 2.5. I would prefer the fraction. But it's okay if you give me the decimal. It is completely up to you. But again, that is the value of x here. That measures 2.5. All right. Example number 3 says use the similar figures to solve for the missing side lengths. This time I actually have more than one. Set up a proportion statement to help. So I see that I have to solve for x and I also have to solve for y. So let's go ahead and solve for x first. And I'll try to keep my work over here on the left, and on the right we'll go through and we'll solve for y. So let's take a look at x over here. So from J all the way to k, what side is that corresponding to, right? I went from an angle that had 3 symbols, so here's the angle that has 3 symbols, P, to the one that has 2, so R is the one that has 2. So those are the corresponding sides there. I'll use x over 20. So if I want to write it that way, x over 20, okay, make sure that we're consistent when we match it up to a different side. What I'm going to do is I don't want to compare it to the left over here because I don't know what y is, right? That's not gonna help me if I have 2 missing variables. So I'm going to compare it to the bottom. From L to K is matching up from Q to R. So again, if I used x over 20, I better keep that same pattern going. I better be consistent. I'm going to say 18, right, over 12. So let's go through and actually multiply. Let me change colors here. I am going to need a calculator just to help me out quickly multiply these couple of things together. So what is, when I multiply this way, 12 times x, that's just 12x, is equal to, and then let's multiply the other way, cross multiply. What is 20 times 18? That is 360. Well, when I divide both sides here by 12, I get that x is equal to, what's 360 divided by 12? That gives me 30. So x here measures 30 units. All right, so again, that is one value that I found. Let's go through and now find y. All right, let's go through now and find y. Let me change colors. And again, think of this as maybe even resetting the problem. And again, we know actually what x is here. I can even use that to my advantage. I know x is now 30, so I can cross off the x and write 30 in there. And then again, that might make your life easier when you're trying to solve for y. So let's go through and try to solve for y. I'm going to use from J to L. That's corresponding to P to Q. Okay, so I'm going to say 21 over y. 21 over y is equal to, and again, just match it up to another side. For this one, I'll go ahead and use the bottom. I'll use the bottom again. 18 over 12. 18 over 12. Let's go through and cross multiply. 18 times y is just 18y is equal to 21 times 12. Let me use my calculator real quick. 21 times 12, that gives me 252. Feel free to use a calculator. Divide both sides here by 18. 18 divided by 18 is just 1. We get y is equal to 252 divided by 18. That gives me a total of 14. So there we have it. We found both missing side lengths here. Side y, I'll cross that off. That measures 14 units, whatever that is, feet, inches, centimeters. All right. Example number 4. One more time, this one says, find the value of x that makes triangle ABC similar to triangle DEF. All right, so this one's a little bit weirder. So take a look at where x is. It's down here from D to F. So the bottom side of these triangles, let's go ahead and compare those. Compare it to AC. Let's set up that proportion. So I'm going to say AC. So I'm going to say 8 over from D to F here, which is 3 parentheses x plus 1, is equal to, and of course, just compare it to another side. I'm going to compare here to from A to B. So from A to B, that was 4. I'm going to compare that to D to E, which is 12. All right, so we have to go through it now. We have to solve this. It is going to take a little bit more work, but let's go through and distribute. Before I can cross multiply, I have to distribute the denominator, or distribute the 3 in the denominator. 3 times x and 3 times 1. Let me copy the top, right? The top just stays the same for now. It's 8. But what's 3 times x? That's 3x. What's 3 times 1? That's positive 3. And this is equal still to 4 over 12. Well, let me keep going with this and actually cross multiply now. Okay, so when we cross multiply, this is going to be a little bit weird. I'll actually show my work for this step. we're going to multiply this way. 4 times 3x plus 3, but this is going to be distribution. 4 times 3x plus 3, and those are the two things I have to multiply, is equal to, and if I multiply this way, I'll show my work again, that'll be 8 times 12. So let's go through and just solve this algebra 1 problem. Let's go through and just distribute and multiply. 4 times 3x is 12x. Whoops, too many technical difficulties, but let's keep going. 4 times 3x is 12x. 4 times 3 is 12, is equal to 8 times 12, which is 96. Now we have, again, still a two-step equation. If I subtract 12 from both sides, I get 12x is equal to, what is that going to give us? 84. And then we have one last thing that we're going to go ahead and do here, and that is to divide both sides by 12. All right, 12 divided by 12 cancels. I'm going to scoot over here and write my answer. X is equal to 84 divided by 12 gives us 7. X is equal to 7. If X was equal to 7, that would make this would make these two triangles similar.